In this video, you will learn how to solve absolute value inequalities. When we talk about absolute value, we're talking about distance from zero. So when we have an inequality such as the absolute value of x is greater than or equal to 2, that means the distance from 0 is more than 2 units away, so you have to be greater than 2. So that would look like this. Or it could be less than -2. If our absolute value is a less than or equal to sign, then we're saying that x has to be less than 2 units away from 0, which means you have to be between 2 and -2. This is called a chain of inequalities. We could also write it as x has to be less than or equal to 2 and x has to be greater than or equal to -2. So it's really these two inequalities separately. However, working with a chain is a little bit easier. So one thing that I find to be very useful is that when it's a great or symbol, great or, it's an or statement. And when it's a less than statement, it's a less than statement or an and statement. And when it's an and statement, we're looking for the intersection of the two sets. So for example, if I had written this as two separate inequalities, greater than or equal to -2 would have been this, and then less than or equal to 2 would have been this, and this blue part in here would have been the intersection of the two sets. When we have an or statement, we just want anything at all that would be shaded. So greater than 2 or less than -2, we want those two pieces. So anything at all that's shaded. So how are we going to solve these absolute value inequalities? Provided that a is greater than 0, because we know an absolute value has to be positive or 0, then the absolute value of x less than a, that's a less than, then we will write it as a chain minus a less than x less than a. If our absolute value is great or greater than, then that will break up as x is less than -a or x is greater than a. So basically, for this second one, we're just going to drop the absolute value and leave it exactly like it is. And for the second piece, we will drop the absolute value and make the number on the right negative. And of course, this holds for less than or equal to and greater than or equal to as well. So let's solve a couple of inequalities. We'll write the solution set in interval notation, and we'll graph the solution set if it's possible. So I find it a little easier to graph it first if you're learning interval notation, so that's what we'll do. So for this first example, we want to make sure that our absolute value is all by itself. We have the absolute value of x is less than or equal to 5. Notice I still have those absolute value bars. It's a less than, that means I can write it as a chain. It has to be less than or equal to 5 or greater than or equal to -5. And on the number line, we know it's got the equal to, so we're going to have brackets, and it's x is between -5 and 5. So one of the reasons we like to write an and statement as a chain of inequalities is it's pretty easy to see without the graph that our interval should be -5 to 5. In this next example, part B, we also have a less than, so this is an and statement and can be written as a chain. So I basically just drop my absolute value symbols and I sandwich it between 5 and -5. And then when I'm working with a chain of inequalities, that's like an equation. Whatever I do to one piece of the inequality, I have to do to all. So I'm subtracting 2 from everything. -7 is less than 3x is less than 3. And then we will divide everything by 3 and get -7/3 less than x is less than 1. So again, this is nice because if I look at this, I already know that my interval notation is -7/3 to 1, parentheses, because I don't have the equal to. And if I were graphing it, I'll do -7/3, which is -2 and a little bit, up to 1, and everything in between. Our next example here is a greater than. So these are a little different. We have to break this up as 2 separate. But regardless, I have to isolate my absolute value. So we'll do that first. The absolute value of 5 minus 2x is greater than or equal to 1. Now I'll break it up into 2 statements. And remember, a great or symbol is an or statement, and you should have that word or inside. So we'll have 5 minus 2x is greater than or equal to 1, simply dropping the absolute value symbols. And then 5 minus 2x is less than or equal to -1. And it's important that you don't break it up until you have your absolute value isolated. So in this case, I'm going to subtract 5 minus 2x is greater than or equal to -4. And then we will divide by -2. And hopefully you remember when you're working with inequalities and you multiply or divide by a negative, you do have to switch the direction of the inequality. So we have x is less than or equal to 2. We'll do the same thing on the other side. Minus 2x is less than or equal to -6. Dividing by a negative, I will switch the direction, greater than or equal to 3. So for our number line, we've got something that is less than 2, less than or equal to 2, or greater than or equal to 3. And so our interval notation will be -infinity up to 2, union 3 to infinity. Okay. Example D, again, is a less than, so this is an and statement. And I'm going to isolate our absolute value first. So I'll add 5. And then I want you to just think about this. Absolute value has to be positive. So is there any way to be less than -5? And the answer is no. And so this has no solution, and we know that up front. But let's say you didn't recognize that and you broke it up. You would say 2x minus 4 is less than -5 and greater than 5. And if you look at the two ends here, this is a false statement. 5 is not less than -5. So hopefully you would recognize that there. And even if you continued, you'd end up with x being between two numbers, but the inequality symbols would not match up. Example E. Notice it's a greater than or equal to, great or, so this is going to be an or statement. And again, this on the right is a negative value. But if we think about what that's saying, we're just saying that the absolute value or the distance from 0 has to be greater than a negative. Well, we know it's always positive, so this is actually going to be true all the time. But let's go through the process so that we can see why that is. So we'll break it up as 7 minus x is greater than or equal to -4, or 7 minus x is less than or equal to 4. If I subtract 7, negative x is greater than or equal to -11, or x is less than or equal to +11. Dividing by a negative, we have to switch the direction. And then I will do the same thing on this side. Minus x is less than or equal to -3, or x is greater than or equal to 3. Now what does that look like on the number line? So here I'm going to put 11 here and 3 here, and I want to be less than or equal to 11, and I also want to be greater than or equal to 3. And since we want any part of the inequality that where it's shaded and the whole line is shaded, the solution here is -infinity to infinity, which again you might recognize right off the bat, but if you don't and you go through the process, you will cover the entire number line. So for our final example here, we have a rational, so a fraction inside the inequality. And that doesn't really change anything. So we're going to look at this, and we notice that it's a great or an or statement. So we'll have two inequalities with the word or in between. So we've got 2x plus 1 over 3 is greater than 5, or 2x plus 1 over 3 is less than -5. I think that I will multiply by 3 on both sides to clear my fractions, and I'll do that for both of these. It's multiply by 3, not raised to the third, just can't squeeze it in there. Okay, so now I have 2x plus 1 is greater than 15, or 2x plus 1 is less than -15. Solving this, 2x is greater than 14, or x is greater than 7, or 2x is less than -16, and x is less than -8. So on our number line, we have 0, greater than 7 would look like this, and -8 less than -8 would look like this. And if I look at my inequality or my number line from left to right, I can do my interval notation, which is -infinity to -8 union 7 to infinity. That concludes this video on absolute value inequalities.